Hello, and welcome back to another episode of the Curiosity Monkey podcast. So, what are we going to talk about in today's episode? Well, today's episode, if you've probably seen the title, is on the Great Pacific Garbage Patch, which you probably know as a large collection of trash and waste that's in the Pacific Ocean, the North Pacific, in this case, for the Great Pacific Garbage Patch. And you probably know it's quite large, it's got a lot of things in it, and also you might have heard there have been cleanup operations that have been conducted to try and reduce the waste within this patch, because plastic pollution and this kind of pollution is not great for the ecosystems necessarily, and we will talk about that. So it is of concern to a lot of people about cleaning this patch up to some degree, also trying to not add to it and make it bigger. So I guess we start with, what is the Great Pacific Garbage Patch? So the Great Pacific Garbage Patch is a collection of marine debris produced and discarded by humans. And that is intentionally or not, so it could have ended up just washed into the sea and got there, or people could chuck fishing nets off the side of their boats and it get there that way. And this debris circulates in the North Pacific Ocean. So this is between the west coast of the United States and the east coast of, say, China, Japan, Indonesia, those sorts of countries in that area. And the debris is transported from all over the Pacific region, so from Asia, North and South America, and then it collects in this large area which we know as the garbage patch. And so how big is this patch? Well, the area is estimated to be around 1.6 million kilometers squared, and this is around 3 times the size of France, according to a 2018 paper from Nature. And is the patch growing bigger? Well, unfortunately, it seems to be growing at an exponential rate. So it is bigger than ever, essentially. And again, it contains trash from all of the Pacific Rim countries. So I guess how does this patch form is a good place to start with understanding the problem. So the whole of the Great Pacific Garbage Patch is contained within something called the North Pacific Subtropical Gyre. And a gyre, you may have heard of this term, you may have not have, is a large system of rotating surface ocean currents that can transport debris. And these currents are driven by various factors. Wind is quite significant, and the rotation of the Earth is also very significant, known as Coriolis force. So, the Earth spinning along an axis, like around the North Pole, that kind of axis, and it causes a force called the Coriolis force, which induces, it's not really a force, but it the Earth feels as a force which allows rotation on large scale things. So you don't see small scale flows rotating, but on the large scale, the Coriolis force is quite significant and causes this rotation, which we see. So the rotation of Earth ocean currents is basically what we're here in the sky. And there are 5 major gyres across the world's ocean. And all of the subtropical gyres in the northern hemisphere rotate clockwise. So in this case, we are the North Pacific Ocean, so the North Pacific Gyre, a subtropical gyre, rotates clockwise. So our gyre is composed of 4 different currents, 4 parts. One is a west flowing along the equator, one is a north flowing along the western boundary, one is east flowing along the mid latitude, and one is equatorward, east on the eastern boundary. So it kind of encapsulates an area within it. And this area is around 20 million kilometers squared and is home to the debris. And the center of the sky is calm and stable, allowing any waste to become trapped. So essentially, waste around the world can end up in any of these currents, and the currents can transport them around this area of kind of calm, stable waters. And if one of the flows is, say, weaker, then maybe the debris can drift out of the flow and into the gyre, like the center of the gyre where it's calm and stable, allowing it to stay there for a long time because there's not much flow in any given direction to transport it away. So it stays in this area. So what do we find in there? Most commonly non-biodegradable and buoyant items, such as plastics, find their way in there. So that makes sense, obviously. If it degrades, such as wood, then it's not going to last very long, so it's not going to build up. Buoyant items obviously float, so they can get transported easily by currents. So combination non-biodegradable buoyant items like plastic are the biggest candidate to find there. So what does it look like if you were to go there and take a photo? You may imagine floating islands of plastic trash and debris forever into the horizon. However, it may surprise you to hear that you mostly cannot see this debris. Much of these plastics that will have been deposited of large items, but over time have worn away into lots of tiny pieces that we know and love as microplastics. So microplastics, being quite small, are very hard to see, thus we cannot really see it by satellite. And the density is around 4 particles per meter cubed, which actually sounds quite low, but if you think about how large the ocean is and how large this garbage patch is, 3 times the size of France, all this plastic being degraded into small particles and dispersed across this large mass, that's a lot of plastic in this area. There are larger items that have not degraded yet and have remained in this section, kind of whole macroplastics you might call them. These are just common things such as plastic bottles, fishing nets, packaging, etc. Microplastics dominate in the number, obviously. They're very tiny and there's a lot of them, but 92% of the mass is made up of larger objects that have not fragmented into smaller pieces yet. So there are large pieces of plastic scattered across this waste. However, if you were to go to the garbage patch, you wouldn't see it as a massive floating island of waste because it's just an area of water where there's a much relatively higher concentration of plastic items than other places in the ocean. So what is the history behind this? When was this discovered? Well, the patch was beginning to be kind of discovered in the late 1980s when a paper by the National Oceanic and Atmospheric Administration came out revealing there was much higher concentrations of plastic debris in this zone compared to other places in the ocean. So they sampled concentration of plastic in the North Pacific Ocean and found there was just more than anywhere else. And since then, more and more publications have brought this to light, kind of how much is in there, what's going on, I guess, like the theory behind it. So as we're talking about the gyres bringing the plastic in. And then also there are other publications that have kind of brought this to the public light and made it into something which is fairly well known. Maybe you don't know exactly what's going on behind it, but most people know that there are garbage patches in the ocean. But here it's important that we note that we are talking about the surface of the ocean. So in the surface layer, some estimates have been between around 45,000 to 129,000 metric tons of plastic in just this gyre, the Great Pacific Garbage Patch. But this is just a fraction of the estimated plastic mass we emit into the oceans each year. An estimated 10 to 20 million tons of plastic enter our oceans yearly, with the world producing over 460 million tons of plastic per year. So a good question to ask, if we're emitting 10 to 20 million tons of plastic every single year, and there's only 45,000 to 129,000 metric tons of plastic in this one gyre, then where is the rest of the plastic? So firstly, I guess there are 5 major garbage patches, one for each major gyre, so there are other gyres around the world as well. So taking this to account, how much plastic is there? And well, there's only a few 100,000 tons of plastic in all of the garbage patches combined. This is just a small fraction of what is released every single year. Secondly, here we were just looking at surface plastic in the garbage patches. And in fact, when we look at kind of how plastic acts in the ocean, much of it sinks over time. So we find plastic suspended through the whole water column and even on the seabed. So how does this happen? First, like plastic, you kind of think of plastic as quite buoyant. So why is it sinking? Well, there are kind of two different mechanisms here. The first one being larger obvious, large amounts of plastic items released are actually denser than seawater, so they just sink over time. And the second one is, over time, different sea creatures and algae, barnacles, etc. grow onto items. So say you chuck a large plastic box into the ocean. Over time, almost a mini ecosystem will form on it. It will become a habitat to some barnacles that grow onto it. And these barnacles increase the density such that it becomes greater than water, and then it sinks. So this means we find quite a large amount of plastic not on the surface layer of the ocean, but in fact deeper in the ocean or even in the seabed, which is a big problem for many reasons, which we will come to in a bit. Another problem is much of the plastics which were initially deposited into the ocean as macroplastics, so large quantities of plastics, big chunks, then break down into microplastics, which are small to see and also behave differently in the ocean. So they're found more dispersed as a concentration in the ocean, kind of like microplastic squash. So what is the big problem with microplastics that sink down? Well, they are very, very challenging to remove, basically impossible. The ocean is very vast. We, as humans, have barely explored a lot of the seafloor, so there's for sure plastics that have reached and explored further around the sea and the seabed than we have as humans ourselves. So as much of these plastics sink down, they are basically impossible to remove from the overall water column or the seabed. So eventually they can be deposited in sediments in the seafloor. So actually seafloor sediment samples have shown a dramatic rise in plastics and microplastics deposited in layers of the ocean sediment as time has advanced. So if you think over time, stuff deposits on the seafloor along with sand, other things, so microplastics and plastics get in there, and then more things get deposited each year, and eventually you can take a sample of these layers and just look for plastic evidence, and you see there's more and more on the top level. So before 1950 there were practically zero microplastics in sediment. However, past then you get more and more microplastics in each consecutive layer going to present, because plastics are very, very common now. Other plastics may just sit on the floor of the sea intact. Additionally, we have a lot of plastic that is not in these gyres. So the gyres do contain proportionally more plastics in concentration than the rest of the ocean. However, the rest of the ocean is also very vast. So another place that is very common to find plastics is actually on shore and just offshore. So the small patch of ocean just between the coast and just out to sea has a lot of plastics found, because a lot of plastic comes from land. In fact, nearly 80% of plastics estimated to come from land, and these essentially wash out to sea and stay in this layer and continually get washed back onto shore again. Now, in fact, this continual washing in and out to sea of the plastics results in quite a lot of stress to them. And it's thought that this cycle of being washed up, getting washed back out, the stress results in the materials wearing down much faster than they would do if they were just sitting in the ocean. So there's thought that it essentially generates microplastics at a much higher rate. Now, this is perhaps why the production dates on coastline plastics are not nearly as old as the ones you find out to sea. They essentially do not survive very long before they atomize into tiny little particles, microplastics that get transported across the rest of the ocean. Now, if you look at garbage patch plastics, a lot of it is actually quite old. The calm, stable waters prevent much stress onto the plastic, so they don't break down as much. Now, if we look at plastic waste as a whole, where does this plastic come from? So as I said before, around 460 million tons of plastic are produced per year. But what does this actually make? So by far the most dominant plastic produced is packaging. So it's stuff used to contain products. And this is around 140 million tons. This is 2019 statistic. So the most dominant plastic use for packaging means that it's almost discarded immediately after the thing it's containing has been used or removed. So this can present a problem because if this plastic is essentially just there to be disposed of at the end, then you're creating a lot of waste that has to be handled in a sensible way to stop it from leaching into the oceans. So what are the sources of ocean plastics? Around 20 to 30% are from marine sources. So fishing industry is a massive source of plastic in the ocean. But 70 to 80% are from land. But if 70 to 80% of ocean plastics come from land, then there's certainly some problem with plastic waste management, because ultimately it's down to how plastic is managed if you do not want it ending up in the ocean. So if plastic is not recycled, incinerated or held in landfill, then it is a risk of entering into a waterway such as rivers, lakes and oceans. So what does this do to our ecosystems? Well, it's not much surprise that plastic pollution has a negative consequence on marine life. And you could probably create a whole episode on this, but I think people get the idea that plastic pollution isn't great for organisms in the ocean. But the point of this episode is more to look at what can we do about the problem, with context for how it is bad. And here I am more generally focusing on the plastic pollution problem as a whole in the ocean, instead of focusing on the Great Pacific Garbage Patch. There is one overarching point as to why plastic pollution is able to be so bad for life, and that is simply because it just doesn't really degrade. The rate of removal is significantly less than the rate of emission into the ocean, allowing massive build-up of plastic in our ecosystems. So the time of degradation of plastics in the environment can range from hundreds to thousands of years. And there are various mechanisms that plastic can break down. UV, chemical and physical degradations are the main ways. But the reason plastics take ages to break down is the reason we love them, because plastics are strong and resistant to damage. So plastics are made of polymers with many repeated units of bonding molecules, and the bonds are very strong, allowing the product itself to be quite strong. But in nature, it takes thousands of years for them to break down and for the bonds to break or decompose into other products such as carbon dioxide. And because of their density, they're able to travel with currents and be transported across the world. So what exactly about plastics is bad for life? Well, firstly, microplastics are able to be ingested and accumulate within organisms. So microplastics, being small to very small plastic particles, are the size of feeding matter, like planktons. So different organisms, such as filter feeders, can easily uptake these microplastics. Now, when they enter the body, it's not fully understood how they interact with the body system, but they have been shown to uptake from the GI tract into tissues, penetrate biological membranes so they can be part of your cells, and even in some cases have been seen to enter the circulatory system, so in your blood vessel, in your heart. And in fish, microplastics have been seen to cause structural damage to vital organs such as intestines, the liver, the brain, and parts of the gills, etc. So if fish have microplastics in them, then you eat the fish, then it's not only a problem for the fish, but also one for you, because you could also be able to uptake these microplastics into your body. So this makes plastic pollution, even in the ocean, not just a problem for the marine life, but also for the people who use it. If it makes the ecosystems unhealthy, such that maybe there are less fish to fish, or that the fish you are fishing are not healthy and there's plastic inside of them, then it's definitely a problem for people too. Secondly, chemicals within the plastics can leach into the environment. So, for example, BPAs and phthalates are found in plastics, say for plasticizers to make plastics more flexible, and essentially other chemicals are added to plastics to make them good for purpose. So these can leach out. We actually did an episode a while ago on phthalates and their effect on the environment and humans, but they are known to be damaging at even very low concentrations. The next point is entanglements and suffocation due to macroplastics, so larger plastics in this case. So marine life can get trapped in large debris such as fishing nets, lobster pots, etc. And this is obviously not great, because if they can't free themselves, then they're essentially going to die if they can't get out. At the very least, it's going to cause problems for hunting, moving around. Also, animals can mistake macroplastic fragments for food and then consume them. And this plastic can get stuck within their throat, or it can get stuck in their stomach. And this could even pierce parts of the stomach or the throat and basically kill them from the inside. Or it could reduce their ability to swallow, eat, be able to survive, and it might just die because they can't actually eat. The stomach is just full of plastic. So this can be lethal, or at the very least highly damaging to the organism. And the last point for this one is probably on the more extreme end, when there's a lot of plastic accumulated in one area. High concentrations of plastic can block surface light to autotrophs below. So autotrophs being organisms such as algae that can photosynthesize, use the light of the sun to produce for chemical reactions, to use energy for chemical reactions. So they are less productive in photosynthesis. So it means there's less algae, less planktons, and that can mess up the food chain below. One statistic from Surface Against Sewage, basically a third of fish caught for human consumption now contains plastics. And this just is one statistic that shows the scale of the problem. As I said earlier, it's not just a problem for the marine life, it's also a problem for us. Because we use the ocean, we rely on it for many different things, so it's good to keep it in good condition. However, in some small cases, I will talk about this because I think it's actually quite interesting, plastic accumulation has actually been positive for life. So in the Great Pacific Garbage Patch, a 2021 study identified 40 plus animal species on 90% of the debris studied. So essentially, they make their habitat out of it, and it allows floating ecosystems of various different organisms that are able to thrive on this floating plastic waste. So in this case, clearing up the garbage patch would be deleterious because the plastic provided a home. However, it actually can be negative as well, because plastic can allow a floating island of life that can then transport across the world and kind of invade other areas that they're not supposed to live in. And this can disturb existing ecosystems through introduction of competitors, for example. So, with all this plastic being released into the ocean, can we reverse any of the damage? Can we remove any of the plastic and take away the damage before it's too late, before all of the plastics or a significant quantity of degrade into microplastics and then disperse across the ocean? Because, let's be real, we're not going to be able to remove or filter the whole ocean to remove all of the microplastics that are dispersed within it. Much of the plastic in the water, even the macroplastics, are below the surface. So they're sunk down, they're somewhere in the water column, maybe even on the sea floor. So how much am I talking when I say most of it? Well, 99.8% is below the surface. So this is not a small chunk. There have been projects that are focused on surface cleanups. So you may have heard of Team Seas, which was, I believe, Mr. Beast collaboration with Mark Rober to remove actually an impressive 15,500 tons of plastic from the seas. But when we compare this to the 10 to 20 million tons of plastic that are emitted every single year into the oceans, this is only 0.1% of what's emitted every year. So essentially 10 hours worth of plastic. And the project cost 33 million US dollars. So that's a huge amount of money for not much benefit, really. So without putting down on Mark Rober's and Mr. Beast's effort for trying to make a difference, there may be far more cost-effective and easier ways that we can tackle the issue. And that is essentially to prevent plastic from ever getting to the sea, because it's much easier to prevent it from getting there than to remove it, especially when it fragments into tiny pieces or even into microplastics, where it's essentially impossible to remove. Effective collection and containment of waste prevents much of the plastic ever becoming a problem, dispersing across the whole ocean area and volume, submerging down deep into the water, breaking into small fragments. So we do produce 450 plus million tons of plastic every year, but it's down to us to contain it and prevent it from getting into the environment. So unfortunately there are a few major contributors to plastic waste in the ocean. So how can we prevent the waste? Well, first, stop trading plastic waste from high income countries to low or middle income countries without investment in waste management systems. So if you are going to trade plastic, I think the UK did trade plastic to various different countries over the time, but basically, just stop doing that without a significant and effective investment into waste management systems so they can contain the waste that's being received. Next, fund and develop effective waste collection systems and infrastructure in all countries to prevent dumping. So why? Well, most oceanic plastic pollution comes from countries with poor waste management systems. So effectively containing the waste, burning it, recycling it, whatever, prevents most plastic from getting into the ocean. So most plastic in the ocean comes from countries with the poor waste management systems, not just the ones who use the most plastic. So rich countries, even though they use a lot of plastic, are comparatively much better at handling their own waste, and they have the capacity to. Next, as I said, in the Great Pacific Garbage Patch, around 50% of the debris comes from marine sources, such as fishing equipment. So preventing dumping of fishing equipment is a huge factor at reducing the pollution, because a lot of fishing nets especially are very easy to trap different organisms in, and they also, because they're emitted far out, they may just remain as large plastics out in the open ocean. So a less immediate concern, but will still have a great impact, is to reduce plastic consumption where possible. So plastic is great. We use it a lot in modern day life. It is essential to our economies. But if we can reduce where we can, then plastic that isn't produced will never end up into an ocean. Development of alternatives to plastics are also great, but they must be scalable, they must also be cheap, and they must also not have other environmental trade-offs. So that is everything for this episode of the Curiosity Monkey podcast. If you enjoyed it, please give us a rate on Spotify or wherever this is uploaded to. Also, if you have any episode suggestions or feedback, you can email at thecuriositymonkey1@gmail.com, or you can DM us on the Curiosity Monkey Instagram account, which I recommend you check out because we sometimes upload reels to there. And yeah, so that's everything. See you in the next episode, and as always, stay curious.